The James Webb Telescope has surpassed itself once again, discovering Z14, the oldest galaxy ever known. But while the early star cluster gives astronomers unique insights into the spectacles of the young universe, it also raises questions. With its astonishing mass and brightness, it once again stands in stark contrast to our current models of galaxy evolution. And so it is that a Webb discovery is once again shaking our cosmological worldview and inevitably raising the question of whether our standard model is still tenable. But what is it that makes Z14 further exacerbate the astronomical crisis? And what does this mean for future research? Stay tuned until the end and find out with us. Astronomers are well aware of the dilemma that the James Webb Telescope has plunged them into. Webb has already added numerous structures to the star maps that, according to our understanding, should not exist at all. As a result, experts have now launched an observation campaign specifically aimed at identifying and analyzing extremely distant and therefore very early galaxies. This campaign has been aptly named Mirage or Miracle, MOM for short, and is therefore concerned with the question of whether what we see out there is a kind of mirage or a full-blown astronomical miracle. Essentially, the MOM campaign is dedicated to verifying whether the light sources discovered with extremely high redshifts actually real ancient galaxies, or whether we are succumbing to a galactic fallacy caused by gravitational lensing effects or other misinterpretations. And this is no coincidence, since the James Webb Telescope discovered 6 very early galaxies with the so-called universe breakers, which existed only 500 to 700 million years after the Big Bang, and yet were almost as massive as the Milky Way is today. Astronomy has been in a painful crisis. In a nutshell, our established models say that there simply wasn't enough normal matter back then to form such star-rich and highly developed galaxies. But since the cosmos doesn't seem to play by the rules we set up, the question inevitably arises as to what's wrong with our standard model, and whether we may have overlooked a fundamental factor in cosmic evolution. This mystery was further deepened by the discovery of JWST 14-0. Confirmed in mid-2024, this galaxy existed just 290 million years after the birth of the universe, making it the earliest known galaxy ever. But even in this case, scientists were confronted with an impossible mass because analyses showed that a galactic premature baby already comprised several hundred million solar masses of stars. But that wasn't all. The spectrum also contained emission lines from oxygen, indicating that several generations of very massive stars must have already gone through their life cycle at the time of observation. The bottom line is that the researchers believe that the galaxy took about 100 million years to grow to the observed dimensions. And it was clear that the idea of a young universe containing only small, very faint galaxies had finally been laid to rest. A new record-breaking galaxy. But now the James Webb Telescope has broken its own record again and found a galaxy out there that is even older than JWST 14-0. MOM Z14 actually entered the cosmic stage around 280 million years after the Big Bang, which means that the light it emitted took a whopping 13.5 billion years to reach our eyes here on Earth. As mentioned above, the experts involved in the MOM campaign are dedicated to putting the luminous outgrowths of the universe to the galactic test. And so it came to pass that Rohan Naidu from MIT, the lead author of the study, set to work with his colleagues to comb through the existing Webb images for potential early galaxies. Ultimately, they identified MOM Z14 as a promising candidate, which is why they pointed Webb's sharp infrared gaze directly at the ominous object in April. As mentioned, redshift plays an essential role in determining age. But what does that actually mean? Well, it's quite simple. Since the universe has been expanding since the beginning of time, light emitted from distant objects is stretched into longer, or in other words, redder wavelengths. And the basic principle applies. The further and longer the light travels, the greater its redshift. And while the redshift in the case of the Jade galaxy was estimated at 14.32, the corresponding value this time was as high as 14.44. In other words, MOM Z14 already existed when the universe was only 2% of its current age. We are therefore dealing with the earliest known witness to cosmic history, which came into being shortly after the so-called Dark Era, when the light of the first stars was just beginning to flood the universe. However, given its astonishing brightness, MOM Z14 appears to be quite compact. It has a diameter of around 240 light-years, making it approximately 400 times smaller than our Milky Way. It contains roughly the same amount of mass as a small Magellanic Cloud, one of our satellite galaxies. MOMZ-14's brightness now exceeds many theoretical models. But at the same time, it is precisely this brightness that enables scientists to identify individual elements within the galaxy. For example, a surprising amount of nitrogen, which once again turns our existing predictions on their head. Experts are familiar with this ratio of nitrogen to carbon from globular clusters. Researchers suspect that these ancient, closely related groups of thousands to millions of stars formed in the first few billion years of the universe. As a result, they are considered the oldest known stars in existence, and the fact that MOMZ-14 is similar suggests that stars formed in a very similar way in this very early chapter of the cosmos. How MOMZ-14 is deepening the crisis. If we take a closer look at the characteristics of MOMZ-14, we realize that it's not only one of the most significant astronomical discoveries of recent times, but also one of the greatest mysteries. This is for the simple reason that in many respects it does not fit into the picture we have had of the early cosmos up to now. As mentioned, MOMZ-14 formed only about 280 million years after the Big Bang during a phase known as the Cosmic Dawn. We are therefore talking about the time when the very first stars and galaxies were forming. However, these primitive galaxies should actually still have been small, faint, and chemically primitive. But MOMZ-14 contradicts these expectations. First of all, it is much more massive and luminous than models predict for this time. In terms of numbers, this means that according to current estimates, MOMZ-14 contains around 100 million solar masses of stars, which is simply an enormous amount for such an early galaxy. This alone raises a fundamental question of how this can be possible. In other words, how could so much matter accumulate in such a short time and so many stars form so quickly? The prevailing theory actually states that large galaxies need billions of years to grow from many small precursors into large star clusters through collisions and mergers. In the case of MOMZ-14, however, it seems as if it has completely skipped this fundamental growth phase. Added to this is a confusing chemical composition. Spectral analysis has revealed that the galaxy already contains extraordinary amounts of heavier elements such as nitrogen and carbon, but in particular an unusually high ratio of nitrogen to carbon. In plain language, this chemical signature indicates that several generations of stars must have already formed and died in order to enrich the galaxy in this way. But how is this even possible when the universe itself was only a few 100 million years old at that time? Stars need time to form, evolve, and eventually explode in supernovae. And normally, stellar lifespans are many hundreds of millions of years. Another mystery concerns the structure of MOMZ-14. As mentioned above, it is extremely compact with an estimated diameter of only 240 light-years. Yet despite this, it shines in infrared like a much larger galaxy. Regardless of its modest dimensions, it produces large amounts of ionizing radiation, which means that it was in a phase of intense star formation at the time of observation. At the same time, however, it appears to contain very little interstellar dust, which, to put it mildly, is rather unusual. Normally, a high star formation rate is accompanied by significant dust formation resulting from supernovae and extensive stellar winds. But why is this not the case here? Was the dust blown out into space by strong galactic winds? Or did no dust grain form at all under these extreme conditions? All these characteristics make MOMZ-14 a real challenge for our existing cosmological models, and it is in good company. The James Webb Telescope is discovering more and more of these extremely early, massive, and complex galaxies. They empathetically demonstrate that the young universe was much more dynamic, structured, and above all, richer in massive galaxies than previously thought. The questions that experts are currently facing, and will probably continue to face in the future, are therefore, is our model of galaxy evolution incomplete? Are there processes that we do not yet understand? And do we even have to abandon our standard model of cosmology? If you like, discoveries such as MOMZ-14 are not just unforeseen anomalies. They are also a real stroke of luck. After all, These confusing anomalies of the cosmos force us to question what we thought was untouchable, and thus give us the opportunity to understand more precisely than ever before how the universe really works. And now we'll explain how the subscribe button really works. Just click on the thumbs up and then on subscribe to never miss a new video from us again. We'll see you soon.